In movies, the throwing knife is portrayed as a highly effective weapon. Generally, when it's in the hands of the main character, it means one of the opponents has only seconds left to live. However, this raises a reasonable question. If throwing sharp steel objects is so effective, why has humanity invented countless examples of close combat weapons? Even in the Stone Age, people used spear throwers, bows, and slingshots for long-range attacks. At the same time, throwing knives, axes, and similar weapons were present in the arsenal of nearly every culture, yet they usually didn't play a significant role. The answer to this question lies in the realm of physics and some aspects of throwing technique. Not long ago, the Federation of Irreversible Sports Knife Throwing conducted measurements of the maximum speed and energy of a throwing knife. For the test, they used a relatively hefty specimen weighing 230 grams. Since the goal was to achieve the highest possible values, the distance to the target was small, only about a meter. The best throw managed to accelerate the knife to 13.6 meters per second, which is just over 49 kilometers per hour. The energy of the projectile was 21 joules. However, everything is understood better in comparison. For example, if we take an English longbow, the initial speed of a 70-gram arrow would be 55 meters per second, or about 200 kilometers per hour, with an energy of around 100 joules. This means that a lightweight arrow has not only a higher speed, but also nearly 5 times the energy, although, as we know, that's still not enough to penetrate a proper helmet or breastplate. The energy of 100-gram bolts shot from a heavy crossbow could reach 400 joules. So, with a mass more than twice less than that of a throwing knife, the bolt had nearly 20 times greater energy. Though this is a somewhat extreme maximum value, bolts fired from modern powerful hunting crossbows possess energy in the range of 200 to 250 joules. Meanwhile, the bolt itself has a relatively small mass, but accelerates to speeds over 120 meters per second. Perhaps it's not entirely relevant, but a bullet needs to have more than 8 joules of energy to cause an injury. To inflict damage capable of reliably taking a person out of action, you need around 80 joules. This doesn't mean that a throwing knife can't cause serious harm or even be lethal. However, much depends on the weight of the projectile and the distance at which it strikes a particular part of the body. Now let's touch on a second aspect. Learning to throw knives isn't particularly difficult if you have some free time, especially when it comes to a completely stationary target. The multi-rotation technique allows for a process of trial and error to find the right force, even at decent distances of about 8 meters, and possibly even more. However, just changing your location can mean you'll spend a long time, so to speak, zeroing in. Many people know how a knife can be thrown accurately at a stationary target from circus performances, but few take into account that for someone throwing knives in the arena, it's a lifelong pursuit, and they likely train in this discipline for as much time each day as a warrior of the past could never afford. But when it comes to using a throwing knife in combat against a moving target, the multi-rotation technique usually falls short. You need a low rotation or no rotation throw, which reduces the effective range to about 5 meters. Records for distance in no rotation throwing are around 15 meters. But again, this is for a stationary target, and it's hard to talk about any good accuracy or reliable sticking of each knife at such distances. As mentioned earlier, throwing knives or pointed rods were part of the arsenal of many cultures. They were also used in the East, particularly in Japan. The Japanese, by the way, were quite fond of throwing weapons, and didn't find it shameful to throw ordinary stones on the battlefield right up until the Kamakura period in the 14th century. However, some throwers had access to more serious weapons, known as bow shuriken. Essentially, this was a broad category of elongated pointed objects, some resembling familiar knives, and others being sharpened steel rods. The length of these items typically ranged from about 12 to 20 centimeters, and the weight varied from 35 grams to several hundred. To eliminate an opponent with a bow shuriken, you had to hit an unprotected area like the neck or other vulnerable spots, which was extraordinarily difficult and required skill and luck, or coat the weapon with poison from local toads. However, this didn't imply instant elimination. In general, this weapon wasn't the primary focus and served as a supplement to a samurai's arsenal. However, around the 16th to 17th centuries, shuriken and shuriken became more widespread, which in our everyday language are known as stars. For simplicity, I will refer to them as shuriken from now on. Actually, describing this weapon is quite tricky, as there are no universal standards. It's essentially a broad category that includes everything from 2 sharpened steel rods bound together to stars with 7, 8, or even 9 points. This weapon is linked to the ninjas who gained popularity in 20th century cinema. crafting an image of incredibly effective fighters, even though, in reality, combat wasn't their primary activity. Ninjas have become shrouded in myths, much like the stories of Vikings and their horned helmets, and they've been given black outfits borrowed from bunraku puppetry, where this style highlighted the stealth of these operatives on stage. In fact, the word shuriken literally translates to something like a blade hidden in the hand or palm. It's often mentioned that shurikens were carried in the folds of clothing or in sleeves, with up to 10 of them at a time. This clearly hints at the compact size of the weapon. While the diameter of modern stars ranges from around 7 to 18 centimeters, it's likely that most of them in the past were closer to 10 to 13 centimeters. After all, concealing a disc larger than 15 centimeters in your hand or sleeve isn't exactly easy. The thickness of shurikens varied from 1 to 4 millimeters, which leads us to some interesting thoughts. The thing is, if we take a modern 8-pointed shuriken with a diameter of about 10 centimeters and a thickness of 2.5 millimeters, its weight would be around 50 grams. Some heftier examples with diameters of 12 to 13 centimeters weigh about 100 to 120 grams, which is generally considered the upper limit for discreet carrying. Simple calculations show that with an initial speed of around 13 to 14 meters per second, even a fairly heavy shuriken would have an energy of no more than 10 joules. For the previously mentioned bullet, that's the minimum amount of energy required to cause any real damage. Comparing the piercing ability of a shuriken to that of an arrow or a crossbow bolt is pointless. The latter will have several times more energy. If we take a look at the length of the points on various examples, it becomes clear that it often just isn't enough to penetrate clothing, skin, subcutaneous fat, muscles, and affect internal organs. If a shuriken makes contact with the surface using multiple points, it increases the area of effect but correspondingly reduces the depth of penetration. Essentially, the design of the star wasn't some kind of technological breakthrough, but rather a simplification. Learning to throw a knife or elongated bow shuriken is actually more complex. However, all the energy of the throw at the moment of impact is transferred to the tip, giving it a higher striking ability. The bow shuriken, on the other hand, expends part of its energy on rotation and has greater sail-like properties. It's easier to hit a target with it, but the loss of initial speed and corresponding energy is greater, resulting in a lower striking ability. In most cases, a throwing knife also tends to be heavier than a shuriken. The movies have made the shuriken a self-sufficient weapon. Ninjas possessed a diverse array of close-range and long-range weapons, yet their primary objectives were gathering intelligence and sabotage. When it came to eliminating a target, they often resorted to more cunning tactics. For example, a ninja might infiltrate a kitchen and disrupt the preparation of pufferfish, stonefish, and other hazardous seafood. Alternatively, they could simply introduce poison, as Sun Tzu famously noted, whose ideas inspired ninjutsu. To engage in 100 battles and secure victory each time isn't the ultimate achievement. The ultimate achievement is to subdue an enemy force without engaging in combat. Reason indicates a sensible application of shurikens, consistent with the philosophy of ninjutsu and arising from their nature. The core of this technique involves launching a series of small shurikens at the opponent's face and vulnerable points, while approaching or, more aptly, during a retreat. A cut face, neck, or even a damaged eye doesn't help with either fighting or fleeing. The shuriken is primarily a non-lethal wounding weapon, the use of which is either a prologue to further combat actions with more serious weapons or a means that should cool the ardor of pursuers. Shurikens were often made from scraps of agricultural tools and low-quality metal, as they were essentially consumable items. They could also be used as a small cutting tool or to throw incendiary devices into various buildings. Overall, the shuriken isn't the fearsome weapon it's often portrayed as to the audience, but it can't be dismissed as a mere trinket either. It's more of a tool for specific scenarios, a wounding and slowing means to create confusion, and in that role it likely performed quite well.